All right, so today we're gonna work a little bit more on factoring with the reverse FOIL method, and then we're gonna review everything we've done this week, or at least everything with quadratic equations. So let's briefly review what we've said so far about the reverse FOIL method. Let's say, actually, let's do so reverse FOIL is method of factoring quadratics. And this is the one where we look at this constant on the end, the one without an x, and list the factors of it, paying attention to the sign that's in front of it. So to get positive 8, you can do 1 times 8, or negative 1 times negative 8, because 2 negatives make a positive, or 2 and 4, or negative 2 and negative 4. Then we ask ourselves which one of these pairs that we just listed, if added, would give you the middle coefficient. So if, excuse me, if we add these two numbers, which pair is going to give us positive 9? So 1 plus 8 gives us positive 9, so we already found it. We know it's 1 and 8. Well, let's just go through the others just to see what we would get. Negative 1 plus negative 8 would be negative 9. 2 plus 4 would be 6. Negative 2 plus negative 4 would be negative 6. So still, we want positive 1 and positive 8. Like we said, for now, it's always going to factor like this with an x and an x. And we want positive 1, positive 8. So we'd say plus 1, plus 8. And we continue to solve by inspection, which again is when we ask what value of x would make this parentheses equal 0. That'd be x equals negative 1. What value of x would make this one equal 0? That'd be x equals negative 8. And when we say this, we're saying if we were to take out this x, what number would we have to put in to make it equal to 0? So if we put in negative 8, where x was, negative 8 plus 8 equals 0. So x is negative 8, x is negative 1. So like we just said, for the factoring we've done so far with reverse FOIL, it's always going to factor to be x and x like this. But it gets a bit more complicated. That's what we're going to look at now. So the reason it's always x is because not only do we list the factors of the constant over here, we also want to list the things that we would multiply to get the x squared term at the front. Remember that if there's no number in front of a variable, it's technically a 1. And how do you get 1x squared? You get it by doing 1x times 1x. And that's it. So there's only one pair here. For all the ones we've done so far, it's just been x squared, 1x squared. That's why it's always been 1x and 1x, or just x and x, which is the same thing. But now we're going to look at what happens when you have something that's not just an x squared. What about 2x squared, 3x squared, and so on? So let's look at one like that. Let's say we have 2x squared plus, let's say 7x plus 3 equals 0. So first step is the same. Take the constant on the end. Pay attention to the sign. How do we get 3? By doing 1 times 3 or negative 1 times negative 3. Remember, if it's positive, it's going to be both the same sign, either both positive or both negative. But now we want to list also the factors of the x squared term at the front. This one, we're not going to really worry about the sign, because for now we'll only deal with positives. So just worry about positives. So how do you get 2x squared? Well, that's 1x times 2x. So basically, when you're breaking down this x squared term, it's always going to be an x and an x. You just have to change the numbers. To get 2, you do 1 times 2. So we say 1x times 2x. So now when we factor this, it's not going to be x and x like we were doing before. Now it's going to be 1x and 2x. Now things get a little bit more complicated. We're going to use a guess and check method to find out the rest. Because before we were just dealing with 1x and 1x, when you multiply, or let's not say that, let's not make it too complicated. So let's just look at the steps we have to do for now. We have a +1, +3, or -1, -3. At this point, we're not sure which pair is going to work, and we can't just add them together to see which pair is going to give us this +7, because now these are not the same. It's not 1x and 1x, now it's 1x and 2x. It turns out that throws things off a little bit. So the method we're going to use to find out which pair is, again, guess and check. So there are 4 different options. We could use this first pair, +1, +3. That could be +1, +3, or it could be +3, +1. We don't know which order it's going to be. Or it could be the other pair. It could be -1, -3, or -3, -1. So there are 4 different combinations that are possible here, and we're just going to guess and check to find out which one's the correct one. Here's how we do it. Let's just pick the first one and plug it in and check if it's going to work. The method to check if it's correct is, we'll just say, like a rainbow method. You multiply the 2 on the outside, and then you multiply the 2 on the inside. So first we're doing 1x times 3. When you're multiplying with an x and a number, you just multiply the numbers and the x just comes along. So 3 times 1 is 3, and because there's an x, it's 3x. And then plus, and then here we have 1 times 2x, that's just 2x. 3x plus 2x is 5x. And now we're going to compare what we just got here to the middle coefficient, or the middle term. We wanted a 7x, but we got 5x. So we need to keep testing. Let's try switching them around. Let's put +3 plus 1. So first multiply the 2 on the outside. 1x times 1 is 1x. Multiply the 2 on the inside. 3 times 2x would give us 6x. 1x plus 6x is 7x. So it looks like we got what we wanted. We wanted a 7x. So we factored it, and that's it. So technically, this same process does happen when, like with the simpler ones we were doing before, where it's just x and x. Let's just say we had, we'll just take the same number. Say it was x plus 1 and x plus 3, like this. So when we were doing this other method, you check which pair is correct just by adding them. So if we had a +3 up in our equation, you'd say, okay, that's 1 and 3. 1 plus 3 would add to give us 4. And so you'd know which pair works. And it doesn't matter which one goes where, because it's x in both of them. But technically, it would be the same thing. It'd just be 1x times 1, 3 times x, and you could check it that way. So this probably isn't too helpful of an example right now because we're not looking at a full problem. So kind of maybe just forget what I just said for now. I think that might have made it more confusing. Just know that we're basically doing the same process. It's just much simpler when you just have an x squared rather than a 2x squared or some other number in front of the x squared. That's the bottom line. So from here, we would solve like we've been doing. So we'd look at the solving by inspection. So this one, and keep in mind 1x plus 3 is just the same as x plus 3. So this would be x equals -3 here. And this other one's not going to be so easy. The way you can tell is because there's a coefficient on the x. Here it's just a 1, or there's nothing there. And here we have something other than 1. So this is one where you're going to want to set it equal to 0 and solve, or you could think about it in your head. But this way is a reliable way to do it. We're just solving for x, and we get x equals -1/2. X equals -3, x equals -1/2. Let's look at another one. Let's say we have 3x squared. Let's see. Let's say we have this. So again, just like the ones we were doing yesterday, starts off the same. Take the constant on the end, list the possible factors. And actually, we just did a 3. Let's make this a little different. Let's say this is, let's do that. So list the factors of the constant on the end. Positive 5, that can be 1 times 5, or negative 1 times negative 5. And then we're also going to come over here to the x squared term, not worry about the sign and any negatives, just worry about positives. This would just be 1x times 3x. Because you know you need x times x to get x squared, and the only way you're going to get 3 is by doing 1 times 3. Again, here we're not worried about negatives, so we won't do negative 1, negative 3. So now we know how it's going to be set up. We know it's going to be a 1x and a 3x. That's always where these come from. It's just whatever ones are here. There could be multiple options here, but we won't get that complicated, at least not yet. Not this week. So now we're going to guess and check. Again, there are going to be multiple possibilities, but let's just start. Let's assume it's going to be this first pair. Also, you kind of get a little hint that it's going to be that first pair, not the second one. Because if you look here, we have negatives, but everything up here is positive. So maybe for some reason it would be negatives, but probably not. So we'd want to try this first positive pair first. Or at least that would make some sense. So anyways, let's plug this in. Let's just start. It could either be +1, +5, or it could be +5, +1. Let's test it this way first. So let's multiply the 2 on the outside. 1x times 5 is 5x. 1 times 3x is 3x. You just put plus in the middle every time. And 5x plus 3x is 8x. So it looks like we already got it right because that's what we're looking for, 8x. So we don't need to do anything else. And then from here, we solve by inspection. Remember that 1x plus 1 is just the same thing as x plus 1. That might make it a little easier to solve in your head. So what value of x is going to make this parentheses equal 0? That's going to be -1. If you plug in a -1 for x, -1 plus 1 is 0. So that's one of our answers. Then come over here. Again, this one's a little more complicated because it has a number in front of x. That's not a 1. So let's set it equal to 0, the whole thing. We're just setting this equal to 0. And then solve for x. Remember, start with any addition and subtraction. Always do it on both sides. So we have 3x equals 0 minus 5 is -5. And then we need to get rid of this 3 because when we're solving for x, our goal is to get it by itself. So we got to get rid of this. It's being multiplied right now. 3x means 3 times x. So the opposite of times, we're going to divide to get rid of it. The 3's cancel out, leaving us with x equals -5/3. It's fine that it's a fraction. That's not a problem. That's a -5/3. And so that's our other answer. If you were to plug in -5/3 here for x, the 3's would cancel out, leaving you with -5 plus 5, which is 0. So that works out. So -1, -5/3. Let's go ahead and try a practice problem. Let's say we have 2x squared plus 5x plus 2 equals 0. So let's go ahead and pause the video and give this one a try. 2x squared plus 5x plus 2 equals 0. All right, so let's have a look. So we'll just write it bigger here so we have some space. So first list the factors of this one on the end. +2, how are you going to get that? Either by doing 1 times 2 or -1 times -2. But again, looking at all the signs here, it looks like everything's positive. So I would think it's probably going to be the positive one. If that doesn't work out, we could try the negative pair. And then we're going to come over to the x squared term and list the possible factors here. Again, only worrying about positive ones. Here, we need to think about the negatives too. For this one, just worry about the positives. And so this 2x squared, you're just going to get by doing 1x and 2x. And again, the way we're getting that is we know it's going to be an x and an x, because x times x gives us x squared. And then we just need to think about what numbers are going to get us 2, and that's 1 times 2. And there's no other pair of numbers. So then let's set it up. We know we have 2 parentheses. And again, we find out what goes at the front just by looking here. We have a 1x and a 2x. And at this point, order doesn't matter. You could put 2x and 1x. Once you put in the other numbers, order will matter. But when you're putting in those two, you could put 2x, 1x, 1x, 2x, doesn't matter. And again, so now we're just going to guess and check. And we said it's probably going to be the positives because everything in our original equation is positive. So let's go ahead and try. We'll just do +1 + 2. It also could be +2 + 1. We'll see if this works. So use this rainbow method to check. 1x times 2 is 2x. 1 times 2x is 2x. 2x plus 2x is 4x. We're looking for positive 5x, not positive 4x. So not that. So at this point, we'd go ahead and switch the order and see if that changes it. So +2 + 1. 1x times 1 is 1x. 2 times 2x is 4x. 1x plus 4x is 5x. So now we have our 5x. We factored correctly, so we're ready to solve by inspection. So just go ahead and set each of them equal to 0, each parentheses. So first this one, 1x plus 2 equals 0. Again, you need to get x by itself and start with any addition and subtraction. So we have addition here, we have a +2. We get rid of it by doing -2, that cancels it out. Whatever we do on one side, we have to do to the other side to keep it balanced. So we do it over there. Then we have 1x equals 0 minus 2, which is -2. And actually, we don't have to do anything else because 1x is just the same as x. And then let's come over here, 2x plus 1 equals 0. Start with addition and subtraction, do the opposite. We have 2x equals -1. 2x means 2 times x, so to get rid of that 2, we're going to divide by 2, the opposite of times. 2's cancel, leaving us with x equals -1/2. So x equals -2, x equals -1/2. Now these are pretty tricky, so let's try another one. So let's go ahead and try practice number 2. And this time, let's say we have 3x squared plus 6x plus 3 equals 0. 3x squared plus 6x plus 3 equals 0. Let's go ahead and pause the video and give this a try. So let's have a look. And we'll go ahead and rewrite it. All right, so what is our first step? First step is we want to take the constant on the end and list the factors of it. Pay attention to the sign. So +3 we can get by doing +1 times +3 or -1 times -3. And then next step, we come over to our x squared term, list the possible factors of this. For x squared, we know it's always going to be x and x. And then we're saying what numbers give us 3. That's just 1 times 3. Again, here we don't worry about the negative factors. So we're ready to set up our parentheses. Again, we find out what goes at the front of them just by looking over here. And there's only one pair, so we know it's going to be 1x and 3x. And then again, we're looking at everything. It all looks positive. So we're thinking it's probably going to be this pair. We could be wrong, but let's go ahead and start trying there. So let's put +1 + 3. Use the rainbow method to check. 1x times 3. Again, just multiply the numbers. 1 times 3 is 3. And then you have the x because it was a 1x. And then plus. And then over here, same thing. 1 times 3 is 3. And we have an x. 3x plus 3x is 6x. That's what we were looking for. So we already found the correct factorization. So at this point, we're ready to go ahead and solve by inspection. This first one is going to be x equals -1, because again, 1x is just the same as x. So if you plug in a -1 for x and add 1, you're going to get 0. So that's one of our answers. This one, let's go ahead and set equal to 0 and see what we get. Again, deal with addition and subtraction first. So -3, those cancel, leaving us with 3x equals 0 minus 3 is -3. Divide by 3, and x equals -1. So we got -1 twice. Let's see, why is that? That's kind of interesting. That would be x squared. I wonder why that is. Let's see, we could divide this whole thing by 3. This will just be a little side note. See if we can come up with an explanation. I think because this would be a perfect square, we won't go into that now. Anyways, we got x equals -1 twice. So x equals -1 is our answer. I'm trying to think if you would need to write that twice. I think you should, but I need to think about that more. But writing it twice is a safe thing to do to show that you got it twice. So x equals -1, x equals -1. All right, from here, let's go ahead and review. The only two other things besides reverse FOIL we have to review are difference of two squares method and GCF method. So again, this week we've been focusing on solving quadratics. And there are different ways to solve. There's a method called completing the square. There's a method called the quadratic formula. There are other methods, and then there's factoring is one method. And then within factoring, we have different ways we can factor. That includes the difference of two squares, the GCF, and reverse FOIL. So that's what we've been working on, solving quadratics by factoring. So difference of two squares, for this one, you want to remember all your perfect squares up to 15 basically, or be able to kind of rediscover them yourself. And just remember 1 times 1 is 1, 2 times 2 is 2, 2 times 2 is 4. And then we have 3 times 3 is 9, 4 times 4 is 16, then 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. So I think up till now, we've tried to keep the numbers on the lower end, but today we'll work a little bit with the higher end, the 121, 144, and so on. So difference of two squares, we'll put GCF for a side now, to the side for now. Difference of two squares problems will look something like this. And so let's remember how to solve them. Let's start with this bottom one, x squared minus 169 equals 0. So when we're solving by difference of two squares, remember we need to factor into this form. Something squared minus something squared equals 0. And again, the name tells you that. Difference means subtraction. We have subtraction. Our difference of two squares. We have two perfect squares. A difference of two squares, name tells you exactly what it is. And then we just need to plug in here. So x squared is always going to be x, because x squared is just the same thing as x squared. And then 169, what is 169? Square root of that. What number times itself gives you 169? That's going to be 13. So then from here, if you remember, it becomes the first one plus the second one, x plus 13, and then first one minus the second one. It's always plus and then minus. And then from here, we're solving by inspection. This one is going to be x equals negative 13, because if you plug in negative 13 here, negative 13 plus 13 is 0. And over here, this one's going to be positive 13. So negative 13, positive 13. Then we'll come up to this one over here, x squared minus 36 equals 0. We know it's going to be something squared minus something squared equals 0. And we know it's going to be x. And then what's going to go in the other one? 36 is 6 times 6. So we put a 6 here. So to find that, by the way, you're just kind of working backwards. You're saying 36 is equal to something squared. So what number needs to go here to make this true? Remember that squared means you're multiplying it 2 times. So what number multiplied 2 times gives us 36? That's our question. And that's how we came up with 6. 6 squared is equal to 36. That's why we were able to replace this 36 with a 6 squared. So then from here, remember, it becomes x plus 6, x minus 6. And here, x will equal negative 6. Here, x will equal positive 6. So let's go ahead and try practice before we move on to GCF. Let's say we have x squared minus 144 equals 0. So let's pause the video and give this one a try. All right, so we know it's going to factor to be something squared minus something squared. We know this one's going to be x. And then what's going to go in this other one? Well, we see 144 here. What is that equal to? It's 12 times 12. So here is a 12. And then it factors to become x plus 12, x minus 12. And then here, x is going to equal negative 12. Here, x is going to equal positive 12. All right, now let's move on to the last method, which was factoring by GCF. So this would be like if we have, let's say 10x squared minus 20x equals 0, or let's say 14x squared plus 21x equals 0. So this is the one where we want to list the factors of these numbers. Careful not to confuse this too much with reverse FOIL. This is a different thing we're doing. So here we're not worrying about the signs or anything. You're not saying positive 1, positive 10, and negative 1, negative 10. Just worry about the positives here. So 10 you can get by doing 1 times 10 or 2 times 5. 20 you can do 1 times 20, 2 times 10, 4 times 5. I think that's it. And what's the greatest common factor? Well, they both have a 5. So we can pull out the 5. And also we know that this one has 2 x's. This one has 1 x. So they have an x in common that we can take out. And then what are we left with? So 5x times what is going to give us 10x squared? First, worry about the numbers. 5 times what number gives you 10? That'd be a 2. And then to get from x to x squared, we need to multiply by another x. Drop down the sign. 5x times what is going to give us 20x? That's going to be 4. 5 times 4 is 20, and then we have that x, so it's 20x. And then from here, we're solving by inspection. You can put this one in parentheses to make it more familiar. And remember, whenever you have something just in front of an x, a number in front of x, it's always going to be 0. You can always double check, set it equal to 0, and solve. 0 over 5 is 0, so x does equal 0. And same thing over here, set it equal to 0. Deal with any addition and subtraction first. We get 2x equals 4. Divide by 2. X equals 2. So x equals 2 and x equals 0. Now let's make this second one. Let's make this a practice actually. So 14x squared plus 21x equals 0. Let's go ahead and pause the video and give this one a try. All right, let's have a look. So 14 and 21, these numbers are maybe a little bit tricky. 14 is just going to be 1 and 14, 2 and 7. 21 is 1 and 21, 3 and 7. I guess they're not that tricky. Biggest number they have in common is a 7. So we can take out a 7, and if you notice the pattern, we can also take out an x. This one has 2 x's, this has 1, so we can take out 1 x from them. And then we're asking the same question, 7x times what gives us 14x squared? 7 times 2 would give us 14, but 7x times 2 is 14x. We need 14x squared, which just means, again, we need that other x. Drop down the sign. 7 times 3 would give us 21. 7x times 3 gives us 21x, so we have everything we need there. We're ready to solve by inspection. This one, like we said, when it's just a number in front of x, it's always going to be x equals 0, because 7 times 0 is 0. And then over here, let's set it up. 2x plus 3 equals 0, minus 3. 2x equals negative 3, divide by 2, and x equals negative 3 over 2. So let's see. I think we'll just briefly do a side-by-side here of these different types of scenarios, because I think we mentioned this before, but for the most part, you won't be told what method to use. That's what we've been doing so far, and on the review, that's what the majority of it is. I may add some problems where you have to figure out which method to use, maybe not. But in any case, most of the time you won't be told what method to use. So you need to figure out which method of factoring is going to work. Sometimes there could be more than one method. So let's just look at some side by side, and you can see what you think if you have a hunch for it yet. So each of these we would factor with one of our 3 different methods. We'll just pause for a second here. You don't need to pause the video. Let's just pause for a second and think about if you could label which one goes which. So one of them is going to be GCF. One of them is going to be difference of 2 squares. One of them is going to be reverse FOIL. So which one's A, which one's B, which one's C? So let's look at the first one. Difference of 2 squares is usually the easiest to identify, I'd say, because again, the name tells you exactly what it is. Difference means there's subtraction, so we know there has to be subtraction. Here there is subtraction. And then they need to be 2 perfect squares, so it needs to fit into that form that we put it in. Can you put this into a difference of 2 squares format? And you could. X squared is the same as x squared, and 25 is the same as 5 squared. So we do have a difference of 2 squares here. So this one, we can use difference of 2 squares method. So B. Now the other 2, GCF and reverse FOIL, which one's which? So reverse FOIL, pretty much all the time, at least for our purposes, there's going to be 3 terms. So notice this one only had 2 terms. This one only has 2 terms. This one has 3 terms. That's a big indicator that there's a good chance it's going to be reverse FOIL. And if you're told that one of these is reverse FOIL, it's going to be this one. That won't always be true. Again, there could be some other cases, but while we keep it simple, that's a safe bet. So reverse FOIL, again, you could check if it works, but this one, based on the options, it's looking like reverse FOIL. Let's double check the last one. Looks like it's going to be GCF, and it would be. Again, it's 2 terms. If you notice, they both have an x. One has x squared, one has x. That means we're going to be able to take out one of the x's, which is a key part of doing the GCF method for quadratics. So here we'd take out 2x. We'd be left with x plus 2, and then we'd be able to solve from there. So this one, we can use the GCF method. Also, as a side note, you can technically use reverse FOIL for any problem that you can use difference of 2 squares on. We won't go into it. We'll just briefly mention you could set it up like this: x squared plus 0x minus 25 equals 0, and you could solve it like that. But don't worry about that. So that's just to give you an idea, so we can start developing a sense for which method is going to work where, or at least which method we think is going to work, and then we can rule out the other ones and try 1 or 2 methods. So from there, let's go ahead and work on to let's work on classwork number 5.